So, welcome to my channel. We will be solving this past exam of mathematics. It is May June 2025. You can see this, and it is mathematics mechanics portion. So we already solved two questions, if you remember. So I will be doing question number three right now. Okay. So here. Okay. This diagram shows a velocity time graph which models the motion of a particle. The graph consists of three straight line segments. Okay, you can read the whole detail. So basically, this is the speed time graph, right? On the axis, time axis on x-axis, speed on the y-axis. Okay, so this is the thing. Okay, so we are told, you see, uh, when this graph is above x-axis, the speed is positive. So the particle was moving in one direction. And when this graph is below x-axis, so the speed is negative. So the particles are moving in the opposite direction, right? And at the end, there's a very interesting thing that the particle starts to travel back to O, coming to rest at O at time t. So at this particular time, right, the particle move back to its original location. So the total displacement is zero, right? It means the total area, the area above the x-axis and area below the axis, this must be equal. This is a key point over here. So we have to find the value of this t, okay? This capital T we need to find, it's not given to us. So we need to find the value of t, but the key point is that the total area has to be equal. Okay, now there are several things are missing over here. We don't know how much is this value. Okay, if you want to calculate the area, we need to know this value. Okay, similarly, we need to know this value. Okay, so unless we know these values, we cannot find the total area. Okay, so finding this speed is easy. Remember, Vf equals Vi plus At. So the initial speed was 5 meter per second. Acceleration in this section, it is given as 5 meter per second square. Let me read it again. The particle leaves O with this velocity 5 meter per second. Yes, this is a 5 meter per second velocity in the beginning. And accelerate, oh, 0.075. Yes. So the acceleration in this section is 0.75 meter per second. Okay, for 20 seconds. So for 20 seconds, it has this acceleration. So 5 plus acceleration is 0.75 and times 20. Okay, so this will give you 15, 20 meter per second. So after 20 seconds, the speed will become 20. So this is basically 20 meter per second. Okay. Now the next thing is given is that then its speed start becoming really start speed started reducing. So it is deaccelerating. Okay. And in this interval from 20 to 40. So in within 20 seconds, its speed becomes zero. Okay. So what is the acceleration over here? Okay, we need to find the acceleration. Remember, if I do write the same equation, I rearrange it. So the acceleration is going to be Vf minus Vi over t, right? Okay, so final speed was 0. Initial speed is 20 and time is also 20 seconds. So the acceleration is minus 1 meter per second square. So in this section, the acceleration is 1 minus 1 meter per second square. Okay. Now, what is the speed over here at this point at 50 seconds? So again, I can calculate Vf equals Vi plus At. So initial speed over here is 20 plus acceleration here is minus 1. So it is minus 1 and time from 20 to 50 is 30, right? So 20 minus 30 is minus 10. So the speed over here is minus 10 meter per second. Okay, so now we have all important points, I hope. So now we will what I will do, I will find the total area, total positive area, and I will equate it to the total negative area. And that way we will try to find the value of t. So what is the total positive area? Let me make it a bit smaller so that I can about yes. Okay. Uh, so here I have two positive areas, 1 and 2, right? And one negative area, 3, in form of a triangle. So this first positive area, area number 1, this is the trapezoid. So this area would be 5 plus 20 over 2 and multiplied by 20, right? This is the first area. The second area is triangle, so it is 1 by 2 and base is 20 and height is 20 as well. So this should be equal to the negative area, which is half, and base here is from 40 to t. So I will say it is t minus 40, okay, into 10. The height is 10. So this will give us the to be equal to the total positive area with the total negative area. And solving this equation will give us the value of this capital T. Okay. Okay. So this will become 10 and 20 plus 5 is 25 multiplied by 10 is 250 plus this will become 200. Okay. And this is equal to, if I make it 5, it is 5t minus 200. I have I'm doing it right. Okay, so 5t is equal to 250 plus 200 is 450. 450 plus 200. So this is 650 and divided by 5. So t is equal to 650 divided by 5. 130 seconds. Okay, so this t is 130 seconds. Okay, so this was part A of this problem. Okay, now part B says find the acceleration of the particle from 50 to t. So from this point to this point. So what is the acceleration over here? Okay, so this we can do using our usual thing, that acceleration is equal to Vf minus Vi over t. So the final speed was 0. Remember, speed was negative and becomes 0 at the end. So final speed is 0 minus initial speed is minus 10 and time was how much time? 130 minus 50. So it is 130 minus 50. So it will be 10 divided by 1/3. This is going to be 80, right? So it is 1 by 8, which is 1 by 8.125, I believe. 1 divided by 8. Yes, it is 0.125 meter per second square. This is the acceleration in the last segment. Okay, it was interesting question. Not it's very difficult. I hope you understood everything. Okay, now this problem, yes, this is a problem of static equilibrium. Okay, so you can see this is the arrangement of three weights. They are balanced, they are static, then nothing is moving. So what do we need to do? Okay, this angle is unknown. Okay, this alpha is unknown and this mass is unknown. So we have to find this M and A in the first part. Okay, so I will apply the what you call the free body diagram at this point, right? So at this point, we have three forces. Let me call this force as T1 and this force as T2. Okay. Now this T1 is basically this M into G, right? And this T2 is M is 25. So this is 25G. Okay. Now, if on this point, I'm opening this point hole. So there's three forces. One is T1, which is mg, and it is making an angle alpha from the vertical line. And this force is 20g. And there's another force which is making an angle of 30 degree. Oh, it's a bit more than 30. And this is 25g. Right? So these are the three forces. Now, these two forces, mg and 25g, they are not at right angle or they're not horizontal or vertical. So I need to resolve these forces into the x component and y components. Okay, so if I apply this equation for the static equilibrium, so I know that sum of all forces along x-axis is 0, right? What does it mean? Around x-axis, I have two forces, the x component of this force and x component of this force. So what's the x component of this force? That is going to be mg into cos theta. So cos alpha. Okay. No, sorry. This is alpha, this is sine. Okay, it's my mistake. This is going to be sine alpha. Okay. And this is okay. Now, what is the x component of this force? This 25g. Uh, it is 25g into sine of 30 degree. Okay. Is it correct? I hope you are following everything with me. No confusion should be there. So T1 into sine alpha, T1 into sine alpha. Yes. Okay. So let's try to simplify this thing. G cancels from G, right? So both G can cancel. And I have M into sine alpha. Okay. This is equal to 25 into sine 30 degrees 1 by 2. So 1 by 2 times 25 is going to be 12.5. So this is one equation we have with two unknowns. Okay. Now, let's apply the second condition that sum of all forces along y-axis is 0. Okay. Now, along y-axis, we have three forces. The y component of this force, the vertical component of this force, and this vertical force of 20g. Okay. So the positive force in the positive direction is the vertical component of this 25g, and that is going to be 25g times sine, this is cosine, yes, cosine of 30 degree. Okay, so this is in the positive y direction. This is equal to all the forces in the vertical direction, downward direction. So this is 20g is one of those forces, and plus the other force is mg, and it is sine cosine, yes, cosine of alpha. Okay, so again, I can cancel out g throughout. It's going to be 25, and cosine of 30 degree is under 3 by 2. So 3 by 2 equals 20 plus m cos alpha. Okay, so from here, we can see that m cos alpha would be equal to this is going to be 12.5 under root 3, okay, minus 20. And this comes out to be, let's calculate, um, yes, 12.5 under root 3 and minus 20. This is 1.65. 1.65. Okay, so now we have two equations and two unknowns. So now this is easy to solve. Uh, okay, so if I divide uh, m sine alpha with m cos alpha, which means 12.5 divided by 1.65. So m cancels and sine alpha cos is tangent alpha. Tangent alpha is if I divide this whole thing, 12.5 divided by 1.65, so it gives me 7.57576. So this gives me alpha is equal to tangent inverse of this number. So, and that tangent inverse gives me 82.5 degree. 82.5 degree. Okay, and I can substitute this value in any of these equations to find the value of m. You can see this m was equal to 12.5 divided by sine alpha. So sine of 82.5, and this calculation gave us the value of m as 12.6 kg. Okay, so I hope you understand both questions. They were not too difficult. Okay, uh, you need to understand the logic behind them, so that you should be able to solve these questions quickly in the timely manner in the exam. Thank you very much for watching. See you in the next video.